Steam generator, boiler. Part 1C continuing. Water tube boiler. Fluidized bed combustion, FBC boiler. Advantages of fluidized bed combustion boilers. 1. High efficiency. FBC boilers can burn fuel with a combustion efficiency of over 95% irrespective of ash content. FBC boilers can operate with overall efficiency of 84% plus or minus 2%. 2. Reduction in boiler size. High heat transfer rate over a small heat transfer area immersed in the bed result in overall size reduction of the boiler. 3. Fuel flexibility. FBC boilers can be operated efficiently with a variety of fuels. Even fuels like flotation slimes, washer rejects, agro waste can be burned efficiently. These can be fed either independently or in combination with coal into the same furnace. 4. Ability to burn low-grade fuel. FBC boilers would give the rated output even with inferior quality fuel. The boilers can fire coals with ash content as high as 62% and having calorific value as low as 2,500 kilocalories per kilogram. Even carbon content of only 1% by weight can sustain the fluidized bed combustion. 5. Ability to burn fines. Coal containing fines below 6 mm can be burned efficiently in FBC boiler, which is very difficult to achieve in conventional firing system. 6. Pollution control. SO2 formation can be greatly minimized by addition of limestone or dolomite for high sulfur coals. 3% limestone is required for every 1% sulfur in the coal feed. Low combustion temperature eliminates NOx formation. 7. Low corrosion and erosion. The corrosion and erosion effects are less due to lower combustion temperature, softness of ash, and low particle velocity of the order of 1 meter per sec. 8. Easier ash removal, no clinker formation. Since the temperature of the furnace is in the range of 750–900 OC in FBC boilers, even coal of low ash fusion temperature can be burnt without clinker formation. Ash removal is easier as the ash flows like liquid from the combustion chamber. Hence less manpower is required for ash handling. 9. Less excess air. Higher CO2 in flue gas. The CO2 in the flue gases will be of the order of 14 to 15%. At full load, hence, the FBC boiler can operate at low excess air, only 20 to 25%. 10. Simple operation, quick startup. High turbulence of the bed facilitates quick startup and shutdown. Full automation of startup and operation using reliable equipment is possible. 11. Fast response to load fluctuations. Inherent high thermal storage characteristics can easily absorb fluctuation in fuel. Feed rates. Response to changing load is comparable to that of all fired boilers. 12. No slagging in the furnace, no soot blowing. In FBC boilers, volatilization of alkali components in ash does not take place and the ash is non-sticky. This means that there is no slagging or soot blowing. 13. Provisions of automatic coal and ash handling system. Automatic systems for coal and ash handling can be incorporated, making the plant easy to operate, comparable to oil or gas-fired installation. 14. Provision of automatic ignition system. Control systems using microprocessors and automatic ignition equipment give excellent control with minimum manual supervision. 15. High reliability. The absence of moving parts in the combustion zone results in a high degree of reliability and low maintenance costs. 16. Reduced maintenance. Routine overhauls are infrequent and high efficiency is maintained for long periods. 17. Quick responses to changing demand. A fluidized bed combustor can respond to changing heat demands more easily than stoker-fired systems. This makes it very suitable for applications such as thermal fluid heaters, which require rapid responses. 18. High efficiency of power generation. By operating the fluidized bed at elevated pressure, it can be used to generate hot pressurized gases to power a gas turbine. This can be combined with a conventional steam turbine to improve the efficiency of electricity generation and give a potential fuel savings of at least 4%. A. Atmospheric fluidized bed combustion AFBC boiler. Atmospheric fluidized beds use limestone or dolomite to capture sulfur released by the combustion of coal. Jets of air suspend the mixture of sorbent and burning coal during combustion, converting the mixture into a suspension of red-hot particles that flow like a fluid. These boilers operate at atmospheric pressure. B. Pressurized fluidized bed combustion PFBC boiler. Compressor supplies the forced draft, and combustor is a pressure vessel used for cogeneration or combined cycle power generation. The first generation PFBC system also uses a sorbent and jets of air to suspend the mixture of sorbent and burning coal during combustion. However, these systems operate at elevated pressures and produce a high-pressure gas stream at temperatures that can drive a gas turbine. Steam generated from the heat in the fluidized bed is sent to a steam turbine, creating a highly efficient combined cycle system. There is a diagram to show you the process of PFBC boiler. Solids lifted from bed, rise, return to bed. Steam generation in convection section. Benefits: more economical, better space utilization and efficient combustion. Fluid. This CFBC technology utilizes the fluidized bed principle in which crushed 6-12 mm size fuel and limestone are injected into the furnace or combustor. The particles are suspended in a stream of upwardly flowing air. 60 to 70% of the total air, which enters the bottom of the furnace through air distribution nozzles. The fluidizing velocity in circulating beds ranges from 3.7 to 9 meters per sec. The balance of combustion air is admitted above the bottom of the furnace as secondary air. There are the diagrams to show you the process of PFBC boiler. To be continue. Next video is the water tube bubbling bed boiler. To be continue. Next video on water tube bubbling bed boiler. Keep watch show views for more technical and informative videos.